Okay, our first study is going to be that of one object where we know the acceleration and we're trying to find a particular force, in this case the force of friction. We have a 5 kilogram block, an applied force of 32 newtons, and an acceleration of the block of 3.2 meters per second squared. So the first thing I want to do is to set up my axes as well as draw my free body diagram, and I'll start with drawing my axes and then go to my free body diagram. So what you want to do is pause the video and go ahead and draw for yourself the free body diagram and set up your axes. Okay, so let's look at first setting up my axes, and to do that I'm going to draw my x-axis along the horizontal and my y-axis along the vertical. And I do want to, and to represent to draw my free body diagram, I'm going to represent the object as simply a dot. I have my frictional force, or not my friction, my force F. I then have what I think is my frictional force in this direction. And the whole thing is accelerating in the horizontal direction. And that's my free body diagram for this particular case, in the horizontal direction. Now in the vertical direction, I of course have my weight, which would be mg, and that'll just be the 5 kilograms times the acceleration of gravity. And then of course there is the normal force. Alright, the next thing I want to do is state Newton's second law. So take just a minute, pause the video, and state Newton's second law. Okay, Newton's second law is that the net force is equal to the mass times the acceleration, both vectors. Once you've stated that, now what you want to do is write out Newton's second law in component form. Newton's second law in the x direction, Newton's second law in the y direction. Pause the video and give yourself some time to try to write it down for yourself. Okay, you see that I have written down the equations in both the x-axis and the y-axis. Of course, we have that the applied force minus the frictional force is equal to the mass times the acceleration in the x direction, and the normal force minus the force of gravity is equal to 0. Notice we can say that simply because the block is not moving in the vertical direction. Now, can we find the resultant force? Well, what is the resultant force in the x direction? That's simply equal to mass times acceleration. So we can write out that's going to be 5 kilograms times 3.2 meters per second squared. And that's going to be equal to, and that's going to be equal to 16 newtons. But our applied force is 32 newtons. So what is our force due to friction? That means, of course, that F minus F equals 16, which simply states that 32 minus F equals 16, and so F is equal to 16 newtons. That is our force of friction, the force that we needed to find. Now that we've found the force of friction, let's go on to a little more advanced topic and try to find out, can we find the coefficient of friction, in this case coefficient of kinetic friction, given that we now know the frictional force? Well, what is the relationship between the magnitude of the frictional force and the normal force? Take a minute and write down the relationship. Pause the video if you need to. Well, that relationship is that the frictional force is equal to coefficient of friction times the normal force. And from the y component of the equation, we have that Fn, the normal force, is equal to mass times the acceleration of gravity. And so that is simply equal to the coefficient of friction times the mass times gravity. Well, what is the mass times gravity? Well, that's simply equal to mg is equal to 5 kilograms times 9.8. And that's equal to, get my calculator, 49 newtons. But the force of friction is 16 newtons. So mu times 49 newtons, the coefficient of friction times 49 newtons, has to equal to the 16 newtons of friction. So the coefficient of friction will be equal to 16 over 49. And that's equal to, getting to my calculator, 0.33. It is a unitless number. There is, since you're dividing newtons by newtons. And that is the end of problem for this particular study.